So, hello and welcome to the last informational lecture style uh, lesson of the Intro Java series. Today we'll be going over abstract and static. This will be arguably the last of the kind of built-ins for Java. There's still the Java standard library and, proper ways to do certain things here and there, and like dependency management and class path and all that kind of stuff. But that's outside of the scope of this course. Um, and you've actually been doing a little bit of it already without even knowing, thanks to using the integrated development environment. So once you get these things done, you'll be able to start developing proper applications. And without further ado, let's dive in so you can get that point done and handled. Today's probably going to be a bit shorter. Um, I need to stop saying so much, and we will cover what is abstract and static, basically. This will tie in well with the interface classes that we've been having to create a kind of more complete application design. So any spare time we have, we'll probably use for kind of doing application design, setting up class hierarchies and these kinds of things. But the main focus is going to be ensuring you understand what abstract and static is. So far, so good?
Yeah,
Cool. All right, so what is abstract? Um, it's a keyword that basically says, actually, let me step back a second. Um, Abstract is kind of a metaphor in the sense of, in English, we have the concept of abstract and concrete, whereas abstract is kind of conceptual, kind of not in the physical real world, and something concrete is something that you can like see and touch and feel and um, hear and all these kinds of things. Abstract is along those lines, not something like abstract art, though I guess that's also kind of a metaphor. But so the way that's applied in code is that we have classes and objects are supposed to be concrete representations of a classification of types of objects, right? Abstract prevents that concrete instantiation of objects. Abstract says, hey, you have this class, and you cannot create an object from the class, which kind of is a little bit counterintuitive for like object-oriented programming things, because the reason we have classes is to make objects. So why would we have classes that can't make objects? And that's what we're going to explain. So um, abstract is a keyword that you put before the word class. So when you're writing a new class like class car or something, you would say abstract class car if you wanted to make it abstract. Um, you can also apply abstract to methods, and we'll cover that in a little bit. So they can be applied to classes and methods. As mentioned, you cannot create objects from them. You cannot instantiate objects from abstract classes, similar to interfaces. You can define method signatures and method bodies. You can define a method body, unlike interfaces. But if you only want to define a method signature, the way interfaces do, you can do that as well. Both are possible with abstract classes. If you try to construct an object, if you say you have an abstract class car, and you try to do new car, Java will say no, you can't do that. And interfaces, you can implement multiple interfaces, right? And then whatever cross-section, I don't know if that's the right word, but whatever the combination of the various methods that those interfaces define, you have to implement. However, abstract classes, if you want to inherit from them, that follows a normal class hierarchy. So you can only inherit from one abstract class. You can't use several abstract classes together and have a new class inherit from many. It's only one, just like with a normal class. Additionally, interfaces only allow definitions of methods that are public. We didn't really mention that in the past, but it's a little bit implied by the fact that interfaces are, well, by name, supposed to be an interface to something, and an interface should be public for others to use. Abstract does not behave in that manner. Abstract, if you remember from our scopes discussion, abstract classes can have private, protected, and default or package private properties and methods as well. We'll cover more about that when we go through examples. That one's a little bit harder to understand. But so far, so good?
Yeah, I think I'm following.
Cool. So cool, you have this thing. It's kind of like an interface, but kind of not. When should we use it? A good rule of thumb is often if you're creating an interface and it's not a purely behavioral interface, like going back to the car example, like drivable, that only defines a behavior, right? It doesn't define an interface to some process or system, which is another way that interfaces can be used. So if an interface is not solely behavior focused, you may want to use an abstract base class. Base is the reason we use the term base is it means that we intend that we will create other classes that inherit from this class. So if, again, using the car example, let's say we have let's say we have a vehicle interface, an iVehicle, let's say, and then we can have an abstract-based car, right? And all vehicles, they need some way to turn their ignition to turn on, right? So we could define that in our abstract base vehicle, and then any other class that inherits from our abstract base vehicle gets that method for free, and then we don't have to worry about it. However, we don't want the abstract base vehicle to create an object itself because we haven't defined things like how does it drive? Because that's going to be different per vehicle. So that doesn't belong in the base vehicle because it's going to be different for each type of vehicle. So again, in this case, moving on to the second bullet point, when you want to enforce some logic in your child classes, using the vehicle example, like turning on the ignition, but require the children to add more logic themselves, like a drive method, because driving a car is different from driving an airplane, for example. So far, so good?
Yeah.
Cool. And just to kind of reinforce, the reason you want to use an abstract base class when using an interface is because chances are, if you're using an interface, you already have some kind of base logic in mind that all of the classes implementing that interface are going to need. But an interface doesn't allow you to define that logic. So use the abstract base class to do that. And so then the question becomes, well, why even use an interface? Why not just use the abstract base class alone and ditch the interface? That gets into a concept called dependency injection, which is outside the scope of this class, but I do recommend you research it. Dependency injection, because maybe the abstract base class, the abstract base vehicle, going back to the example, maybe the ignition does some work that we don't always want to do for a vehicle interface. For example, if we want to test some things, maybe we don't want to really turn on the vehicle. So we can make a test car that implements the interface but does not inherit the logic from the abstract base class. And that's a case where dependency injection would be useful and why we have the separation between interfaces and abstract classes. However, if that does not make sense, don't worry about it. That's something at the more intermediate level anyway. Rule of thumb, if there's an interface, it's not solely behavior driven, you may want to add an abstract base class. Good?
Yeah, it's okay.
Cool. So this is actually from the previous lesson. We pulled up an example of the class hierarchy of a HashMap, where we have. Do I have my? Why do I have the pointer now and I couldn't find it last time? So our HashMap is our kind of item of discussion for now. And as we discussed a few weeks ago, it implements these serializable and clonable interfaces. But it also inherits from this abstract map, right? This is effectively an abstract base class. They didn't add base to the name. That's just convention. That's just their choice. It doesn't really matter. The name has no impact. It's just choice, as you probably know already. Now, notice that they have the map interface, and then the abstract map, and then the hash map. This is basically the pattern that we just talked about, where the map defines all of the method signatures that are required, like we learned about in the past with interfaces. And then the abstract map defines some properties and methods that all map objects will have. And that way, when we create a specific map object or map class, like a HashMap class, we don't need to define a whole bunch of code again because it's already defined an abstract map. Okay, so it basically just saves us some typing. Does that make sense?
It's a little confusing.
Okay. Do I have? I do not. Notes? Nope, that's not what I'm looking for. Captions? Nope. Tips? Nope. Q&A? Nope. Notepad. Let's do it. So, oh, you know what? This is perfect. Except it's not going to be in a second. Crap. Okay, now it's perfect. All right, so let us say, is this on the record? Yes, it is. Great. So let's say I have some, let me switch my language over here to Java real quick. Ah, you also be Java. Excellent. So let's say I have a class. Dude, I told you to be Java. Why aren't you? Maybe it's just being slow. You know what? Let's make a third one. Can we make a third one? Split right? Yeah, we can. Is this a different file? No, it's not. Or crap. Hold up. Yes. Excellent. Okay. So let's say I have a public interface map, KB, right? And it has crap. Oh man, I don't want to implement a hash map. Okay, I'm going to make a fake hash map. So let's say I have some get interface which takes in a k string, or wait, no, a k key and returns a v, right? So this is this might be confusing, but we'll try it. And then let's say I also have a public int size, which will return how many items are in the thing. And then let's have a public abstract map. Hello, map kv I need you to be Java. And then this will do these kinds of things, and it will implement map kv. I'm not sure if you actually need this implements. I'm not sure why it's not code highlighting either. This might not be 100% correct code. And then I can say something like protected backing array. This is not a correct map implementation at all. Like not even a little bit. So don't. It's actually kind of embarrassing that I'm doing this, but I'm just trying to go fast. And then it returns what would that be? Backing array dot width, right? And then I'm not 100% sure we need the override either, but whatever. Okay, this is all also very tiny. All right, that's probably a little easier for you to see. We can get bigger. Okay. Actually, we maybe can a little smaller. Okay. Can you see this?
Yeah, I can see everything.
Cool. So, apologies for that taking so long. So this is kind of a really stupid toy and highly inaccurate example of the previous diagram. However, it will serve our purposes for demonstration. So we have a map interface. And on this interface, I've defined two methods, get and size. So get will take in whatever type of key we've given and return whatever type of value we've given for defining the map. And then we have a size, which will return how many items are in the map. Okay? This is the interface we have defined.
Okay.
And then, crap, can I make another? Hold up. Does this work? Can I do this? No, I want to get low. I want to get low. Oh, getting low. Okay. And Java this. Sorry. Kind of going all over the place here. Actually, Adam probably has a shortcut for that too. Oh well. I believe this is correct syntax, but who knows? Getting confused with my languages here. Okay. So that defines our interface, and then we create an abstract map. Now, remember, an interface cannot define properties. So it cannot define variables, but an abstract map, because, class, that's important. Let's make this a little smaller again so you can see all the text. This abstract map is still a class, right? And classes can have properties and methods. So what we have is we're creating a backing array, right? This is basically where we're going to store our stuff. Now, a real hash map is not necessarily implemented like this. I'm just being fast. Or a map in general isn't even this way, but whatever. So we're defining this, and then any other class that inherits from this abstract map will automatically get this backing array, right? That's something that an abstract class can do that an interface cannot do, because an interface cannot have properties. And then we also say, hey, the get function, we're going to leave that to whatever child class to implement. We're not going to implement it ourselves. But the size class, we're going to implement that ourselves, and then here it is. So then later, on our actual implementing class, our HashMap class, we can inherit from the abstract map class here, and we'll get the backing array already, and we'll get the size method already. We don't have to type that. We got that from the parent class. We got that from the abstract class. So all we have to do is define get, and we're done. Does that make a little more sense?
I think so.
Or is it even more confusing?
No, I think it's okay.
Okay. So basically, in one of the simplest benefits, there's many, but for beginning, starting out, the way that abstract classes can benefit you is if, oh, you know what, let's actually demonstrate. Java, please. Java, 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 Java. Okay. So, in this example, damn, being a little picky about my scroll bars. Size is, again, going back to the simplest benefit of using abstract classes is because I've defined this size method already, I can have multiple child classes and they don't need to define the size method because it's done already. The abstract class did it for me. We're extending or inheriting from the abstract map class, so we already get that for free and we don't have to write it. So that's the simplest benefit of abstract classes. Does that make sense?
Yeah, I think it's okay.
Cool. All right. So, and again, remember that the abstract map cannot be instantiated itself. You have to make some child class in order to create an object from it. Okay, so for now, that's pretty much it for abstract classes. Oh, and abstract methods. I actually forgot. And I was reviewing yesterday, and I have since forgotten already. Hold up, we're just going to Google it at this point. Abstract method. Oh, wait, do we need to mark it? Oh, we need to mark it, don't we? I apologize, my example is terrible. So here, we need to actually say that this is an abstract method. And then we can not define it. And then I think we can actually not need to use override too. Get out of here. Yeah, we actually don't need to. We don't need the override either when we do it that way. So, yeah. So basically, if you don't want to provide an implementation, if you just want to provide the signature and be finished, you should mark the method as abstract. That's what it was. I apologize. I forgot that. And though, if you forget it like I did, chances are that your development environment, like IntelliJ or whatever, will see this and be like, hey, do you want this to be abstract? Let me just add it in there for you, and it'll take care of it for you. You don't really need to worry about it. It's only in cases like this where you're writing in a kind of raw text editor that you would need to remember this. So good.
Yeah.
Cool. All right, so that's it for abstract. We're gonna revisit again when we do some examples. But let's move on to static. So static again is another keyword, and it is one of the reasons it's often taught alongside abstract is because static basically defines the property or method on the class instead of the object. For example, if I have some class, my thing, and I need to tell it Java again. Hello, Java. There we go. If I have int count things, right? And then I have some constructor. Right? Pretty standard thing going on here. You've seen this before. And then let's actually yoink this real quick so I don't have to type everything again. And then we can do my thing var equals new my thing with one count things, right? Now, this is what we've learned before, right? We define some property in the class, and then when we create the object, let's make this public actually. We can then do something like this. And that works, right? And then if we define, I know this is pretty much review, but review doesn't hurt. These will print two different things. This will print count 1, this will print other 2, right? Because the count things property of var is different from the count things property of other. We learned that previously as encapsulation. Does this, do you remember this part?
Yeah, I kind of remember.
Okay. You kind of what?
I kind of remember.
Okay, cool. So static does something different. Static defines it on the class instead of the object. So if I were to do something like this, if I were to try to do, this would fail because var is an object, right? It's an object of my thing. And static says this is on the class, not on the object. So if I wanted to access this, what I need to do is this, because that's referencing the class and not an object from that class. Does that make sense?
I think so.
Yeah, it's one of these things where you're like, okay, I see what it's doing, but why?
Yeah.
Yeah. So there are reasons for this. But real quick, just to demonstrate again, a little example. Java has a math class, and in that math class, there's a random function that is defined as static. And this is how you would call it. Again, you would use the math class, and you would just say random on the math class. You wouldn't create a new math object and then try to call random on that. You don't do that because that's not static. And also the math class is abstract anyway, so you can't create an object from it. So that's just another example, but I think the one we showed here is a little bit better. So one thing worth noting is abstract classes, you cannot create objects from them, right? So they're actually a good place to put static properties and methods. The math class being an example. It's abstract. You can't create a math object. That does not make sense. It does not let you do that because the math class is abstract. However, it does have static methods, like this random function. So if you've worked in any other languages, you can think of the combination of abstract classes and static methods as kind of like namespacing. If you're not familiar with the concept of namespacing, don't worry about that. It's basically just a way to group properties and methods. However, note that if I were to do something like this, it changes on the class anywhere I use the class. Anywhere. It's kind of a global thing. Okay. So when should you do this, right? Like the but why part. Um, so in the past, we learned about final. Final basically says after this value is set the first time, it cannot be changed. Um, and so you'll often see public static final, kind of like here. You'll see that often used to define constant values. Often in programming, you'll have times where like you need to use some value like a number or a string or whatever. What's an example that beginners would understand? Yeah, I guess this car example is the way to go. So let's say you have a car class, right? All cars, like traditional cars, are going to have 4 wheels, right? And that's not going to change. And there's no reason to define the number of wheels on each and every individual car if it's not going to change and it's going to be the same for all of them. That's just why would we do that? There is no reason to. So instead, what you can do is you can say, hey, I'm going to define some final value. It's not going to change. It's going to be constant. Right? It's going to be public so anyone can access it. And then I'm going to make it static so that it's on the car class instead of each individual object. And so that way, if you want to see, hey, how many wheels does a car have? You can do car.numWheels, and then you can see how many wheels a car has. You'll often want, so many times people go, well, why not just use the number 4? Because programming is crazy, scary stuff. And by that I mean there will be times where maybe someday all cars now have 6 wheels. And so rather than going and finding where you've typed the number 6 throughout your entire project, it's easier to just change this number to 6. And then anywhere you've referenced this, it's now 6 and you're done. Does that part make sense?
Yeah, I think so.
Cool. This is actually a really common pattern. You will see this very often, especially in logging systems. Are you familiar with the concept of logging when it comes to software?
No.
Okay. Are you familiar with the concept of keeping a log in like scientific settings?
Sure. Yeah.
Yeah. So you keep a log of what happened, right? Like you write down each thing that happened, when it happened, where it happened, what happened, right?
Hmm.
Um, we have the same concept in software, and we just call it logging.
Okay.
So you'll find often in logging libraries that the they'll have logger objects, right? And you can set different logging levels. Like I want to see only when there's an error, or only when there's warnings or errors, or show me kind of informational stuff and warnings and errors, or show me everything, show me all the debug information, right? You have these different levels of logging. And you'll often find that they'll have some logger object, but also on that logger object, they will have a public static final thing. It might be an integer, it might be a string, whatever. It's whatever they choose. And they have these different logging levels of like error level or warning level or info level or debug level. And in that way, you can just reference that without having to figure out like, oh crap, how do I tell it that I only want it to be in debug mode? Was it level 4 or level 5? Crap. You can just say, hey, logger.debug mode. Done. Does that make some more sense?
Yeah, I think it's okay.
Cool. So, that's pretty much the main purpose of static properties, is mostly just for kind of lookups. You can use it for other cases, but it's pretty rare. There's not really a need for it. So that's when you would want to use static properties. When it comes to static methods, it's actually much simpler. Say you have some class, you have an object, you have a function, you have a method on that class, but it's not actually using any of the object's data. It's just doing general work with whatever inputs it's given. In that case, why have it on every object? Just make it static. So basically, if you're not using data from an object's properties, if you're not doing like this dot whatever, just make the method static. Done. Easy. GG easy. Finished. And most of the time, if you're using an integrated development environment like Eclipse or IntelliJ or whatever, it will suggest, hey, you're not actually using the object's data. Do you just want to make this method static? And you'll be like, yeah, sure, whatever you say, and everything will be good. Does that one make sense?
Yeah, I think so.
Cool. So for example, let's say, just again, I know you said yes, but just repetition and reinforcement is a thing. Let's say we had, my thing has an add method, and public int add a int b, like we've done a whole bunch of times before, and we just return a plus b. Is this using any data from the myThing object?
No.
No, it's not using count things, and static things is static, so we don't care. So because of that, just make it static. It doesn't need to be on every single thing object. We can just make it generally available on the class. There, done. That's when you use a static method. Cool?
Yeah.
All right. Wow. We are 45 minutes past the beginning of the class, and that is all of the material pending going through some examples together. So do you have any questions about what we've covered so far before we do some example work?
No, I think I'm okay for now.
Cool. Then let's, for purposes of practice, let's go ahead and open up IntelliJ or Eclipse or whatever it is your preference is, and let's make a new project. Oh, I don't have Java installed on the new computer. Let's fix that. Do I want to go open or do I want to go Oracle? I like open source, but now I have to make another choice. OpenJ9 sounds fancy. It's got open in the name. Let's do it. Hopefully this is fast. Sorry for the delay.
No, it's fine. It's okay.
Okay, cool. Go, 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 go. It's almost done. Okay, go. So, I'm not going to use any sort of library, so we're just going to next. I mean, we might as well use the template. Why not? It creates the main method for us. It saves us a little bit of typing. And we're going to use my projects folder. And we're going to do CodeSeoul, abstract, and static. Again, you can call yours whatever you want. org.codeseoul.java.intro. Sounds like a good base package to me. You can make your base package whatever you want. Yes, please create the directory. Except that's actually not where I wanted to put it, but whatever, I'll fix it later. Okay, cool. So, full screen that. Don't care about your tips. That's cool. And, all right, so, nothing new here. You're familiar with this by now, I hope. What is this Untitled 104 crap? Oh, there we go. Still indexing, huh? Oh, looks like it's done. I don't know. Okay, so example. Give me a second. I just want to, I'm pretty sure I have some kind of, oh. Oh, hey. Great. Actually, I do have an example. Cool. I can just use my example. Oops. Over here. Thanks. Okay. So, what is my example? Did I use instruments or did I use pencils? All right, let's do pencils. So, okay. I did a funky one. All right, so let's do a full kind of project structure thing going on. Let's start with an interface. So let's do in your package, right-click new, go to Java class, and let's call it an iWritable. Now I know I said that we may or may not need an abstract class for behavior-focused interfaces, but for purposes of our example here, we're just going to use behavior focused. It's not that you can't use behavior focused interfaces with abstract classes. It's just usually if you're not using behavior focused, it is likely that you want the base class, the abstract base class. If you are using it, then it's questionable. So we're going to do an iWritable as our interface, right? As in writing like with a pen or pencil. And we're going to make it an interface. So do that, you should get something like this. You with me so far?
Yeah.
Cool. All right. So again, this is a behavior style interface. So we're going to say public void write is the behavior we are going to define because writable things should be able to write. So no surprises there. And let me know when you got that down.
I have it.
Cool. Sorry, excuse me. Following that, let's start with our abstract class. So let's do an abstract writing tool as our base class. You can include the word base, you can not include the word base. It's kind of your choice. I'm opting not to here. It doesn't really matter. It's just convention of whatever kind of place you're working at or group you're working with. We're going to define it as a class. You should get something like this. And first thing we want to do is say public abstract class, abstract writing tool. All right, and let me know when you're at that point.
Yeah, I have it.
Cool. Sorry, just organizing my stuff on my other screen so that I can easily explain stuff. Great. So our writable. Oh man, the screen is so big I can do all sorts of stuff. Oh baby, that is good. Okay. So our abstract base class should implement. Why did I not implement? Okay, my example is not great. Should implement our writable interface because that is kind of the purpose of this. And so yeah, my example is crap. Okay, I'm just gonna go on my own here. A writing tool. We're defining a writing tool as something that you press to paper, and when you touch it to the paper, it leaves some kind of mark. That's what we're going to define as a writing tool. So technically, a paintbrush could be a writing tool, but whatever. That's what we're constraining our project here to. So with a writing tool, we might have two properties that we might use. For example, we might a writing tool might use some kind of material. Public? Do we want to go public? No, let's go protected. And it might have like a thickness. Let's say in millimeters, because you should always have units when you're talking about distance and things. Distance and dimensions. And then we can also do something like, let's set up a public getter, so get material. And IntelliJ will actually autofill that for us. We can also do the same with thickness, get thickness in millimeters. Boom, there we go. Let me know when you're at that point. Also, is the text too small? Can you see this? I should probably make it bigger.
I can see it's okay.
Okay, I'm gonna make it a little bigger anyway, cause what? Okay, custom, I guess. Wait, hold up. Font. Yeah, there we go. 18. Yeah, that's good. Okay, so you're at this point?
No, I'm still typing.
Okay.
Okay, I have it.
Cool. All right, so let's actually do one more thing. Let's set up a constructor. Abstract writing tool. Oh, we should make this public. And it should take in a string for the material and an integer for the thickness in millimeters. And this dot material, typing is hard. This dot thickness. Cool. And let me know when you get up to there. Oh, I know why this example is broken. Because this was actually past homework. And it is meant to be the portion that the students were to complete. Wait, no, it's not. What the hell? Okay, I guess I ditched it. Have you got this written out?
No, not yet. I'm still typing it.
Okay.
So I have it typed out, but I have an error, and I'm just trying to figure out what I've done incorrectly.
Do you want to share your screen?
Sure. Um,
Okay. So, that's semicolon before the curly bracket.
oh,
Yep.
yeah, that didn't belong there.
Yeah, no worries. It happens all the time. Cool. All right. I'm glad that was an easy one.
Thank you.
Yep. So, crap. Where was I going after that? Right, okay. So now we're going to create another class. So right-click your package over in the project pane, do new, and do Java class. And we're going to make a pencil. I was debating for a moment there. Let me just split this down real quick. Cool. All right. You got your pencil made?
Yeah, I have it made.
Okay, great. And then what we're going to do is we're going to define a constructor for, wait, are we? Yeah, we're going to define a, yeah, we will define a constructor. So public, add a new line here, public pencil. And it will, similarly to our abstract writing tool, it will take in a material and a thickness in millimeters. And we will just, actually, you know what? You know what? We don't even need to do that. We don't need to do that at all. Sorry. Scrap that. We're gonna define that public method, or that write method. Like this. It's interesting that, why wasn't it complaining? Why isn't it complaining? It should be complaining. Hold up. I want to see if this compiles really quick, because I'm tripping out on something here. So please ignore this for a moment. Was it 0.2 millimeters or something? I don't know. Oh, we do need to do that. All right, cool. Yeah, there we go. That's what I was looking for. Okay. Interesting. Oh, that's why. Oh, oops. Extends abstract. There we go. Okay, sorry. I forgot something. So, let's get rid of this. Let's make our pencil class extend abstract writing tool. All right, and then you will notice that it will be complaining that we have not implemented the write method. Let me know when you're at this point.
Okay, it's complaining.
Cool. And you can either mouse over this and click implement methods, or you can do Alt-Enter and then select implement methods. You'll get this dialog and you can just hit OK. Done. GG easy. We do need the override. I was wrong earlier. Then,
I have it.
cool. We also need to define our constructor. I was wrong about that earlier too. I apologize. So let's make our constructor public pencil. Takes in a material and a thickness in millimeters. And we can just call, since abstract writing tool already does what we want to do, we can just call super to use its constructor and we're done. We don't have to do all that stuff ourselves. So far so good?
Yeah.
Cool. And then we can do, actually, you know what? I wonder, would that be better? Yeah, you know what? Okay, sorry. I just had a good idea of how to demonstrate things even better. Let's actually take this right method and let's get rid of that. Let's define it on our abstract base class here. So let's do public void right, sorry. And let us do system.out.println. I'm writing this.material at this.thickness in millimeters thick. So let me know when you got that down.
Okay, I have it now.
All right. And then let's go ahead and do a little test thing going on here. In our main class, let's define a new iWritable object. We'll call it pencil, if I could freaking type, and we'll create a new pencil object. We're going to use graphite, and it's going to be 0.2 millimeters in thickness. And let me make this a little, let's get rid of this. There we go. That is terrible. Let's do this. Still not excellent, but better than before. Oh, ha. I apologize. Thickness in millimeters should be a float, not an integer. I'm sorry. Let's fix this. So what we can do is, here's a fun little IntelliJ trick. In your abstract writing tool class, if you right-click integer and you say refactor, you can do type migration. Okay, so if you click that, migrate type of field thickness in millimeters int to, let's make it a float, because we need a decimal point. So if you do that, and you say refactor, it will update all of the references to it. Oh, not all of them. This is still an int. We need to change this to float, and we need to change this to float. And what are you complaining about? Fine, be that way. Okay. All right, so I apologize for the confusion there, but here, thickness in millimeters, the definition, we need to change that to float. The getter, we need to change that to return a float. The constructor, we need to change the input to that for float, and the same in pencil. Sorry about that.
Okay, I think I changed all of them.
Okay, cool. Excellent. So, why is my mouse a hand? Weird. So then, after that, in our main class, once you have this, we can do pencil.write. All right.
Sorry, I have to update the main class.
Not a problem.
Okay, I think I'm
Good.
yeah, I think I'm okay.
Okay, so now let's go ahead and try to run this. So we can click here and just do run main. Nice and easy way of doing it. Hopefully. Okay, there we go. So there you go. I'm writing graphite at 0.2 millimeters thick. Is that what you have for your output?
Yeah, I have that output.
Excellent. Good job. So this is a really convoluted example, right? This is a lot of work, especially because our pencil class isn't really doing anything, right? It's just using the abstract base class's constructor, and that's it. Beyond that, it's not doing anything. However, we can get fancy. So let's go ahead and let's define a new class. So right-click your project, go to New, and select Java class. And let's create a ballpoint pen. Okay. And once you've got that in, make sure class is selected and hit enter. And you will get something like this. Good?
Yeah, I have it.
Cool. So then we can say extends abstract writing tool, just like before. And then we need to give it a constructor. So let's say public ballpoint pen. And at this point, we can do a little bit more interesting things. So a pen always uses what to write with? What does it put onto paper? Or sorry, you're still typing, huh? My bad.
Sorry, can you ask that again?
No worries. Are you? I want to wait till you're finished typing first. Are you finished, or are you still going?
Yeah, I'm finished.
Oh, okay. Um, when you're writing with a pen, what material does it put onto the paper?
Um, the abstract writing tool.
Sorry. A ballpoint pen.
Um,
Like it sucks when your pen runs out of.
oh, you mean ink?
Yes.
I thought you were asking me another type of
Oh,
question.
no, sorry. I'm not. I promise. There's no rocket science going on here. No materials and sciences engineering or anything like that. Um,
Sorry, I was just overthinking.
no, it's all good. That's why I was like, crap. I should probably give a complete the sentence because that would be yeah. Um, so this is always going to use ink, right? So instead of so we'd want to call our abstract writing tools constructor, but instead of taking in a material and thickness in millimeters like a pencil does, it's always going to be ink. So what we can instead do is something like ink, and then thickness in millimeters as whatever. We can say float thickness in millimeters. So do you have that down?
Yeah.
Okay. Now, does this kind of make some sense? As to it's saving us writing a lot of code. So, sorry, I should explain like what I'm asking if it makes sense. um, we have a pencil, we have a ballpoint pen. These are both types of writing tools, and so they extend from our abstract writing tool. And a pencil basically is an abstract writing tool because the material and the thickness are both malleable, just like an abstract writing tool allows. However, a ballpoint pen always uses ink. However, instead of writing a whole bunch of stuff to do all this work all over again, um, we can just say, hey, ballpoint pen, always use ink, and take in some kind of thickness in millimeters as an optional, or not an optional, as an input. Does that make sense?
Yeah, I think so.
Yeah. So we have enough flexibility to write these two things, but with
Hmm.
minimal code. And
Yeah,
that's kind
that
of the
makes sense.
advantage of, yeah. So let's, again, just to demonstrate, let's go ahead and in our main class, let's do a ballpoint pen. And let's say the thickness, I don't know, 0.5 millimeters. I don't know how these things work. Let's do that. And let me know when you got that, and go ahead and run it when it's finished.
I'm running it right now.
All right, I will do the same then. Yeah, cool. So did you
Hmm.
get similar or the same output?
Yeah, I have the same output.
Excellent. All right, so that's kind of a really, really basic example. Um, and we can let's do something a little funky. All right. Now we're gonna show how. So we've shown how the abstract class can help us reduce code while maintaining flexibility. Showing the differences between the ballpoint pen and the pencil. But the question remains of like, why the hell do we need the writable interface? Let's demonstrate why. Let's create one more class. So in your project pane, right-click your package, do new and Java class just like before, and let's create a fountain pen class. And let me know when you have that.
I have it.
All right. And let's have this implement an iWritable. So we're actually going to bypass the abstract writing tool this time. And for fountain pen, we are only going to define. Actually, we don't need to define. We just need to do. It's going to start complaining about the lack of a write method. So let's do Alt Enter or Command Enter or Option Enter. I forget what it is on Mac. And implement methods and implement that write method. And let's do system.out.println. I'm writing ink at variable thickness. All right, let me know when you have that written out.
I have it written out.
All right. So now let's demonstrate this guy by, again, in our main class. Let's do an iWritable fountain is a new fountain pen. We didn't define a constructor because we don't need to do anything in the constructor. We just need to return the object. Now, technically, this write method could be static. However, because I want something that adheres to the writable interface, we're going to leave it as is because I want a writable object. Okay. So just a note to contrast from earlier. All right, so go ahead and in your main class, just write something out like this. And let me know when you have that and go ahead and run it.
Okay, I have it and I'm running it right now.
All right. All right, so far so good. Did you get good output?
Yeah.
All right. Now, let's make this a little nicer. So we're doing a whole bunch of writable variables, doing each one's constructor, calling the write method on each of them. Let's go ahead and let's use a little bit of what we've learned in the past to clean this up a bit. And I know we haven't used static. We're going to get there in a little bit. Let's go ahead and let's do, at the beginning of our main class, here, I'm going to close all this other stuff. Is that okay? I'll take that as a yes.
Sorry, I'm just trying to switch between windows. Yeah, it's fine.
Sorry. All right. Oh yeah. God, I forget that not everyone has dual monitors. I am a terrible person. Okay. Sorry. Yeah, if you need me to pause at any point, just let me know.
That's okay. I'm fine with switching back and forth.
Okay. So let's define a new writable called let's make it a writable array. Okay. And let's call it writing tools. And let's set it to, oh God, I hope I get the syntax right. It's been a while. Let's just take all these constructors. Yeah, okay, I think this is the right syntax. And let's just put these guys in here. And then for iWritable tool in writing tools, tool.write. There we go. So this cleans up our code a great deal. So take some time and get this written out. And let me actually test that it's going to work the way we expect it to. Pretty confident it will, but we should always test. Yeah, it looks good. And let me know when you've got this written out and we can check stuff. And then move on to some staticky things.
Sorry, I had an error, but I found it.
Oh, good job.
Okay, I've caught up.
All right. And were you able to run it? Does it run well?
I'm running it right now. It seems to be working.
Cool. So great job. Hopefully this kind of demonstrates how we were able to use the abstract writing tool class to really simplify our code for the pencil and the ballpoint pen. But by still using the interface, it allows us the flexibility to make something like a fountain pen.
Oh wait, actually, I realized I skipped something.
Oops.
Sorry.
No, it's all
Just
good.
give me one moment, please.
Yeah, no worries. Let me know if you need to see something. Do you have any trouble?
Yeah, I have an error, and I'm thinking the problem is one of my braces.
Okay, do you want to share your screen?
Um,
Or you want to hammer at it
okay.
for another minute?
Okay, I'll share my screen.
Okay. All right. Well, looks right. Scroll down.
Yeah, it's just
Ah,
in line 26. So I'm
so
thinking
line
it's.
25,
Hmm.
you do not want to comment on line 25.
I see. Eh,
Uncomment that. There you go. All right, now try it.
yeah,
Looks good. Great job.
thank you.
Cool. No. And stop that. To kind of just this is not really so this example is actually pretty nice for demonstrating um, the benefit of saving how much code you're writing using an abstract class while permitting flexibility by using an interface. Um, and so we kind of get the best of both by in this example. However, we haven't done static, and honestly, this is not the greatest example for static, but we're just going to throw something together real quick. So let's hop over to our fountain pen, and let's add a new method. Actually, not a method, not a method, not a method. gross. Yeah, I'm not happy with this. I should have chosen a different example. Yeah, let's just make it a method. Screw it. It could be a method. Well, no. Let's do a property, because that's what you're going to see more often, I think. So let's do public static final float thickness equals. Oh crap! Wait, it's not going to be a float. It's going to be a string. Sorry. And let's make that variable. Also, I apologize. I didn't mention this during the presentation, but normally when we do something like a final property, we make it all caps. That's kind of the signifier that, hey, this is final. You're not gonna change this kind of thing. All right, so let me know when you got that line added.
I have it.
Cool. And then back in our main class, let's do system.out.println. Let's just do something like fountain pen thickness, and we can do plus fountain pen dot thickness. Now, this is kind of a trivial example. This is not a great example. I apologize, but it will demonstrate how that thing works at least. Why is it saying this is not used? I'm using it over here. What are you talking about? What's wrong with you? What? Yeah, what? Weird. And let me know when you got that.
I have it.
Cool. And then go ahead and try running it. And you should get similar output to here.
Yeah, I have the same thing.
Cool. All right. So that pretty much covers it. We didn't cover everything that we covered in the presentation, but this is kind of the core important stuff. Do you have any questions?
Could we just go through the example one more time, just so that I can be a little bit more clear as to what static is doing here?
Oh, what static is doing. Okay.
Mm.
I thought you were going to say everything. It's like crap. Okay, let's do it. All right. So in this case, like I said, man, I should have come up with a different example. Crap. Oh well. So in this case, you'll notice that in our main file on line 18, I'm not using the object inside writing tools. Right? I'm calling thickness from the fountain pen class directly. And in this way, it's basically, so static properties and methods are really just variables and functions that you store on a class. They can be anywhere, but for purposes of logic, you just put them on the class. What's a good way to explain that? So this kind of thickness variable here, or I'm sorry, thickness constant because it's final. If I were to do something like this, right? This would effectively be the same thing, except I can't do this in Java. Everything has to be inside a class. Everything. So defining something, you'll notice that this is not inside the main class. This is out in the scope of the Aether. And you can't do that. Java doesn't, just no can do. So if I want to define some value, whether it's a property or method or whatever, it has to be part of some class. Now this doesn't make sense to belong to a specific fountain pen instance, right? Because it's true of all fountain pens. So why would I make it belong to each individual fountain pen object? That doesn't make sense. So instead, we define this value, this thickness value, as on the fountain pen class by saying it's static. And then to use it, instead of representing a fountain pen instance, like a fountain pen instance would be like writing tools 2, because 0, 1, 2 dot thickness, right? This doesn't work because, again, it's on the class because it's static. It's not on the object instance. Does that make any kind of sense?
I think so. I think I get it, but I probably just need time to like let it sink in.
Gotcha. I'm trying to think. There's got to be a better example. Oh, yeah, duh. Okay. SL4J documentation. Come to me. God, this is bright in my room. Holy, 1 second. I need a light to not kill my eyes. Okay, much better. Show me user manual. This might be a little too complicated, but maybe we can run with it. God, this page is... I want the API reference. Just give me the reference. No, not download. Documentation. Reference. Java docs. Great. Okay. So... I don't know. Packages, I guess. Let's look at the root. Let's look at the helpers. I think that's all we need. Factory logger. That's an interface. Crap. Logger factory friend. What? Util. This is not what I was looking for at all. Crap. Yeah, log4j. That's what I want. That's what I want. Javadoc. Nope, not download. Javadoc, please. Yes, thank you. Beautiful. Public API and internal utility classes. Cool. Wait. Yes. Yes, this is perfect. And then yeah, it's probably fine. Wait, no, actually, go back. I want this interface event logger. Yeah, that's what I want. Yes. Yes, beautiful. Okay. This is what I'm looking for. Over here. Why did you do that twice? Okay. So, this is the log4j logging library. I mentioned earlier that log4j is that logging is a good example for staticky things. So I mentioned earlier that logging has different levels, right? So debug, error, warn, info, these kind of different levels of logging. Actually, this is probably a better way to show. and they're hierarchical, right? So off means no logging, fatal means only logs that are killing the process, error, warn, okay? Now, they have this custom type, this custom class called level. And level does a whole bunch of stuff, right? It has all this stuff here that we don't know about and we don't care about. I don't care that a level object has a read resolve method. I really don't care. I don't know what it is. I don't care what it is. I'm not going to use it. But in order to configure a logger, if I want to make an event logger to, write my events into a log to document what my application is doing, I need to, if I want to log an event, I need to provide this level object. But I don't want to go figure all this stuff out. I just want to have the level object for the level that I want to write my logs at. So the level class, this is actually maybe a little bit confusing. The level class provides all of these static fields, all, debug, error, that output level objects that I could then use to log events. So let's say, now this is not going to work in my example because I haven't imported log4j and all that kind of crazy stuff. But let's assume that I have imported log4j and I've created an event logger. And I want to log an event, say the thing happened, and I need to provide some logging level. Well, in this case, I can just say level dot error. There's a system logger now? No way. Seriously? Yo, what's up? I can just use that. Oh, baby. Oh, this is great. I didn't. Okay, so let's do an actual example. Crap. Logger logger equals new logger. Wait, why are there? Oh, this is an interface. Okay. Whatever. And then this wants what? Name. My logger. Sorry, we're kind of figuring out some stuff now. What is this complaining about? Private access. Okay, what's the public interface for it? Protected. Okay, I don't want to look through all this. What is it? Java util logging.logger. I promise this is going to make sense by the time I get it done.
No worries, it's okay. I'm following along.
Okay. Why is your constructor protected? May be obtained by calls on one of the getLogger factory methods. Okay, that makes sense. Logger.getLogger. There we go. What are your, okay, my logger. Beautiful. Okay, that's what I wanted. Dot warning. Yep. Cool. All right, great. I have an actual example that will work. Cool. Let's test. Beautiful. Oh, baby. Okay. So, I don't like that formatting, but that's okay. I have just learned Java has a built-in logging system, which is cool. I was not aware it had that. So this is actually an excellent example for static. So let me let me do something like give me the package. I just want to see the package. No, why can't I click you? Java util logging tree. Cool. So logger level. Beautiful. Okay. So there we go. Okay. Let's make this a little bigger. Get logger. Okay. So this is actually an example of a static method and a static property. The logger class, they don't want you to create a logger yourself. They don't want you to use the logger constructor yourself. Reason being, there's probably a whole bunch of stuff that they have to do to create the logger properly, and it probably requires input that you as a person cannot figure out. And or they may need some ways to plug certain things in or whatever. I'm actually not sure why they did it this way, but I'm sure they have a good reason because these people are smart. So instead of calling the logger constructor, we can call this getLogger method, a static method, on the logger class. And then that logger class's static method will create a new logger object to give to us. Does that kind of make sense?
Yeah, I think so.
Okay, cool. So to just kind of demonstrate briefly, if I had some logger and I had like a private constructor, basically no one else can call this, only I can call it. And then I have a public static get logger method. Then I can do, oh, whoops. It's basically something like this. That's funny. Where I don't want to give public access to call the constructor directly. Why they did that, I'm not sure. I don't have enough information to understand why exactly they did that. However, in order to get a fake logger object, they provide the static method, which I can call on the class because it's static, to get a new logger instance. Does that make sense now?
I think so, yeah.
Okay, cool. I mean, I know you said it made sense before, but you know me. So when you see something like this is actually called a factory method. Later in your spare time, if you look up design pattern factory, and I'm actually going to link it in the factory method pattern. I'm going to link it in the code here so you can see it later. They actually describe why people use this, how it's used, all that kind of stuff. So you can read about that later. That's a more intermediate level thing. But this is an example of a factory method. Okay, it produces an object without using where you're not using the constructor. I wonder what that is. And that's an example of a static method. Okay, and then when we call the log method, which is here, the log method takes in a level and a message. However, level is a type of level object, right? I don't know what the hell this level object is. Let's go take a look. that looks more complicated than I want to deal with. I don't want to deal with this hash code and this bundle name and mo. I don't care about these things. But the level class provides level object instances as properties that I can just retrieve statically from the class. So I can just say, hey, give me the warning level, and then I can pass that in as the input to my loggers log method. So this right here is the level object. If I follow this, public static final level, its name is warning, and it's a new level object with all this stuff, whatever this stuff is. Does that make sense?
I think I'm following.
Yeah, this one's a little bit more difficult. Basically, the way you can think about it, this method needs a special type of object called level. I don't know how to make a level object. Let's look at level. Oh, cool. It gives me a whole bunch of level objects on the class. I don't have to build them myself. I can just pull them off the class. I'm going to do that. That's the thinking process. So rather than like really dive in deep and figure out what is a level object, just use the ones that the class gives you. Because the class defines them statically, and you can access them directly on the class, like this, instead of having to do something like level my custom level equals new level with level name 1500 resource bundle. I don't know what all this means, right? So this would be the way of doing it, like not statically. But they on the level class, they just have these predefined level values that I can just pull off the class and use. This might be even more confusing than the fountain pen.
It's okay. I think I get the concept generally.
Yeah. It's I guess the concept is, I feel like the concept is relatively simple. Like, okay, the variable is on the class, not on the object. That's it. That's the concept. Done. The method is on the class, not on the object. That's the concept. Done. But then, why would you do this? When would you do this? That's the more difficult thing to understand. And this is like is actually a really good example of when you would do this, but without writing our own logging library from scratch, which is not in our scope right now. It's maybe a little difficult to understand. But basically, if you find yourself writing some code and you're writing either a property or a method, and you're like, this belongs to a fountain pen, like generally, but it doesn't belong to a specific instance of a fountain pen. It belongs to all the fountain pens. Then it's static. Does that kind of make sense?
Yeah, that makes sense.
Cool. Why didn't I just say that at the beginning? So that I think that if you can keep that concept in mind, like this property or method belongs to this classification of stuff, but not to any specific one, then it should be static. Because then it's defined on the classification of things rather than the actual things themselves. Sound good?
Yeah.
Cool. All right. So we went from being like an hour and 15 minutes early to having 5 minutes left. So let's figure out how to computer briefly. Um, Here we go. So now that we've done an example in addition to the presentation, any questions about what we've covered today?
No, I think I'm okay with today's stuff.
Great. All right. So, homework. Um, I added a little bit more structure to this. Um, the this is I was a little bit worried that the things taught in the last lesson were maybe not clear or maybe didn't have enough practice with them. So we do have a little bit of exception handling here. Okay, you are going to work with the runtime exception. So this is kind of homework for last class and this class. It will use abstract. It will use static. Wait, will it use static? Wait, yes, it will use static. And it looks big and scary, but the second page is tiny. So, as always, if you have trouble or if you don't want to bother your sister, you can always message us on Discord. I'm not going to go over the homework in detail because um, I'm hoping that it is written clearly enough that because I do recall feedback that it was not clear previously. Um, I'm hoping that it is clearer this time. If it is not, please tell me, and I will fix it and clarify on whatever you need. Um,
Okay. I
and
think it's just my sister being picky, really, but okay.
I mean, six of one, half dozen of the other. Like the
Mhm.
computer is the pickiest one of all, and if the person telling the computer what to do doesn't know what to do themselves, still a problem. So,
Mm.
um, yeah. So beyond that, oh crap. I will add additional resources because I forgot to do so. I apologize. I'll get it done shortly, and I will post up the code and video probably tomorrow night. Um, and beyond that, do I not have a? I don't have a Discord link on this page. Well, if you need help, you can always message us on Discord.
Okay.
So yeah,
Um,
what's up?
for next week, I'm just wondering what's happening with the final class.
Yes. So um, next week is our kind of practicum. It is kind of like a final exam, except there's no grading. This is a voluntary thing. Um, so what we are going to do is we're going to make a text-based adventure game, and you will use all the stuff that we have covered today, or not today, that we have covered throughout this class to make uh, just a little text game where like you're an adventurer, you're in a dungeon, and you're trying to find the gold or win the prize or whatever. It doesn't have to be a text adventure game. That's just how I set it up. You can really do whatever you want. Um, but the design of it is such that you will use everything that we have practiced in this course, and it's basically a kind of work together thing, um, where basically because there's just the two of us, it's going to be more of a pair programming exercise where um, I will we'll look at the design requirements together, and basically you'll go through it, and I'll give you help and tips and all these kinds of things as it's being built. Does that make sense and answer your question?
Yeah.
Cool. Does that sound like a good way to exercise what you've learned, or do you have any alternative ideas?
No, I think it's great. It sounds a little intimidating, but you don't grow without a challenge, right?
Yep, there you go. It's actually meant to be really intimidating.
Oh, good to know.
Yes, that's perfect. Because by the end of it, you're going to have something really cool and you're going to be like, what? I built this? um, because usually the way that this works is. Oh, and for people watching the recording, I apologize. You will not be able to participate in this. I will have some stuff that you can reference, but this is meant to be an interactive thing, the last lesson. So I apologize to you online folks. But um, it's going to be more of like Here's the requirements. Do you remember how to do this? Okay, you can find the information in this lesson. Do you remember how to do this? No, that's okay. It's over here. Here's how you do it. This kind of stuff. And it's basically just kind of repetition of what you've been learning.
Mhm.
And because a lot of this, the difficulty about teaching a language like Java is that to get something working, you need a lot of knowledge, which is annoying and stupid, but necessary. So, but then it's so much knowledge that splitting it up into like 2 hours per week, it's difficult to keep track of everything. Like, there's stuff in lesson 2 and 3 that you probably forgotten, or at the very least need some sort of refresher on. And that's kind of the purpose of the practicum is, hey, all the stuff that you've learned in the past, we're going to put it to use now, and you're going to get to practice and use all that old stuff and put it all together to make something interesting. Does that make sense?
Okay. Yeah, it does.
Cool. It's going to be scary, but you already have all the tools you need. It's just a matter of like remembering where it is and then remembering how to use it. And I'll be there to guide you and help you.
Okay. I will look forward to this then with very nervous anticipation.
You're going to be fine. No one, to my memory, uh, everyone has completed it.
Okay,
So
well, there's a first for everything.
trust me, you're way ahead some of the other students we've had do this, so you're fine. I think this is the third or fourth time that we've done this Java course, so yeah, don't worry, you'll be fine.
Okay.
Yeah, cool. All right. Any other questions before we call it a night?
No, that's it. Thank you again for another wonderful class.
No worries. Thank you for coming. And again, if you have feedback or questions or anything, message me on Discord or wherever else you can get a hold of me, and I will see you next week.
Okay, see you next week. Take care.
You too. Bye bye.
Bye.